Contingency table is basically a two-way table of counts. So the data are counts because our variables are categorical, and this table organizes the data about two categorical variables. For instance, here is an example. One example is the gender, broken down in single men and single women. The other variable is the type of relationship. It can be committed, can be in a non-committed and non-looking for a partner, in a non-committed but looking for a partner, and does not know. And here are the numbers. Most of the times you are given the body of the table, so you are given this part. And it's always a good idea to add your column and your row of totals. And so I have them in green. Then at the intersection between the two columns of total, you have the grand total, which also represents the sample size. In a contingency table, where we organize these counts that we have collected, there are some distributions that we want to talk about. One distribution is called the marginal distribution and is basically the distribution of the margins of the table, so the row total and the column total. And then we can construct a conditional distribution. We can do, for instance, the conditional distribution for one column with respect to the column total, or one row with respect to the row total. So if we do the column with respect to the column total, this will be the conditional distribution for your row variable, and vice versa. These conditional distributions can be useful, especially the ones on the column variable, when the column variable is basically or independent, like in this case, because we can manipulate the number of single men or single women we will be asking the questions, and so that's our independent variable. So now this data can come in a numerical form or can come as percentages. So if they come as percentages, be careful. So let's imagine we want to construct the conditional distribution of one column with respect to the column total. So if we do it for the first column, it's going to be 115 divided by 385. And that's going to give us as a decimal, I'm going to round a bit, is going to give us roughly 0.3 or 30%. And if I keep going and divide by 385 all my numbers for the column of the single man, then I'll find the following decimals. So this is 0.42. Next one for the people looking, the single man looking, is 23% or 0.23, and the one who don't know is simply 5%. Now, if we do the same for the column of the women, so we are dividing all the numbers by 601, which is the column total for the women. And that will produce 23% or 0.23. And for the second row will produce 65% or 0.65. For the third, the looking, women looking, is 9%. And for the ones who don't know is 3%. And then we can draw a graph, and this graph can be explanatory whether or not there is a relationship between type of relationship and gender. In fact, if we draw a graph, so on the vertical I put my percentages, and on the horizontal I put the categories: committed, not looking, looking, doesn't know, and then I put the single men and the single women so that we can compare them. So for committed and single men in committed relationship, we have about 30%. Men not in a committed relationship and not looking, it's 42%. Men not in committed relationship but looking is roughly 23%. And the one who don't know is roughly 5%. This is for the men. For the women, we find 23% in committed relationships. Those not in committed relationship and not looking are a vast majority, 65%. Those not in committed relationship but looking are only 9% for the women, and those who don't know are only 3%. And so we can see in here that the type of relationship definitely depend on gender, because you can see a lot more women not looking than men and a lot less women looking rather than men. So it depends on sexes. So if we did a test for independence, we would probably find a rejection of the null hypothesis of independent. Now, how to tell if the percentage data are given for a conditional distribution? Like if you see that they add up, like these ones will add up to 1 column wise. Same thing in here, they will add up for 1 column wise, but not row wise, because it's only 0.63. Then you have a conditional distribution for the row variable. The other type of things that can happen, it can be the other conditional distribution, the one that adds up to 1, because we are dividing by the row totals that add up to 1 by row. And then we can have the percentages. So we could do a table where we go 115 divided by 986, and in this case and then we could go 138, we could divide by the total, and in this case all the percentages added up together, they will add up to 1. So look how the data are given to you. Thanks for listening.